Good afternoon. I am Dr. Marty Cummings, and today we will be looking at the tuning protocol for elementary school teachers. This would be in a planning session for elementary mathematics teachers to look at and analyze student work samples. So with that said, let's go ahead and begin. The first thing that I would like to highlight is the tuning protocol instrument that will be used during this planning session. This instrument, as you can see, the authors were former school teachers themselves, and they wanted to really take a closer look at how students actually solved problems in mathematics at an early grade level. The authors are David Allen and Joe McDonald. They invented this because they wanted to make it an easier process to be able to look at and analyze student work. Now, the protocol is broken down into different segments. As you can see, we have the introduction, the teacher preparation stage, clarifying questions, pause to reflect on warm and cool feedback, reflection, and debriefing. If we were to add all of those time frames up, we would have to have a planning session well over 1 hour. But for the sake of this video, I'm going to condense everything. With that said, let's go ahead and begin. This is a student work sample that I'd like you to take a look at. This was a second grade task where the students had to add 2-digit by 2-digit numbers. Now look at this for one moment and see if you can come up with any conclusions to what you actually see. Don't worry about if your comment is right or is wrong. They can add, they cannot add. Just look at the student work sample and see if you can figure out the rationale behind their thinking. After the teachers have had a moment to look at the actual student work sample, the facilitator would then ask questions. We would kind of go around round robin and ask, what did you think? What did you see? What was the student able to do? What were they not able to do? And many times, some teachers would want to look at this and initially say, well, the student can't add. But from looking at and using the tuning protocol, what this actually shows is that the student actually can add. And if you look at this, what the student did was add 5 plus 4 plus 2 plus 3, and they came up with 14. And from using the tuning protocol, we would find out that the student did not have any problem with the adding. It's with the place value. The students really did not understand place value. So this tells me as the teacher a lot of things. It shows me, first of all, where the student went wrong, and also how to plan my redirection plan. Okay, with that said, I know now that the student can add, but they struggle with 1s and 10s, which is place value. So I know now that I have to plan a redirection lesson based on place value. Now, you may ask, how would I do that? What resources are there out there for me to be able to plan a redirection lesson when I know that a student, based on their work sample, is struggling with place value? This is one way you can do that. This is a website that is free of charge. It is called the National Library of Virtual Manipulatives. It's online, and I will provide the website address for you to be able to go to. And like I said, it is free of charge, so you can use this and pull it up at any time. And students can actually manipulate this if you have Promethean boards in your classroom. But one way to plan a redirection lesson is to go here to the addition using base 10 blocks. What this will show the student, we really wouldn't want to start with 2-digit by 2-digit because we know they already are struggling with this concept. We want to break it down and start at a more simple place. We want to start with 1-digit by 1-digit numbers. So as you see here, 5 plus 6, the numeric portion is here, but then we have what I like to call our game board with our base 10 blocks here. We have 5 ones and we have 6 ones. Okay? Now, what the student will be able to do, they will be able to manipulate this using their mouse. And like I said, if you have the Promethean board, they could use the pen to do this in front of the class setting. When you move these base 10 blocks to show that you're adding them together, this is what you will come up with. You had 5 plus 6. Okay? Well, we already know that the student is struggling with place value. They just see now 10 ones or 11 ones that are here in the ones column. Now, to make this more concrete for the student, we operate in the area of base 10. So 10 ones will equal 110. I can verbally tell that to the student, but if I can physically show that to the student, they will better remember that. And look at this process. Now, those 10 ones are really equal to 110. Now, looking at my game board, are my pieces in the correct area? Based on the response of my answer, no, they aren't. Because this 10 block does not belong in the ones column, it belongs in the tens column. And the student would be able to manipulate and move that over and look at what happens at this point. Once you place the base 10 under the appropriate area, the correct answer shows up. So they see it in manipulative form as well as numeric form. Also, this leads to a good lead-in lesson because after addition, you go into subtraction. So, once the students are able to understand this concept, we can then go back and we can click on base 10 subtraction. Okay? With this shows that I have 74, which are 7 tens, 4 ones, and the students can physically see this. Then I have to subtract 17 from 74. I have 110 and I have 7 ones. So, based on the process that was previously explained, the student will be able to understand that if I'm taking 17 from 74, okay, let's start in my tens column. I can take my 10, my 110, and that will cancel out with one of the tens in my 74. Do I have any more tens? No, I don't have any more tens to take from. So, here, I would take my ones and they will cancel out. And the students could actually see this. Now, this is where the questions come in at. The students are at a point where they see, I only have 3 ones, but there are no ones to take them from or to cancel out. So what must I do? Once again, reiterating the concept that we live in base 10 land, and we have to sometimes make fair trades. We can make them up as we did with addition, or we can make a fair trade down with base 10 blocks with subtraction. So basically, we would take 110 and make a fair trade down and look at what happens. The student can actually see that when I moved and made a fair trade from one of my 110s to the ones column, is no longer a 10. It's 10 ones. Now I can cancel out my 3 ones, or my 3 remaining ones. And the students can see that. And the good thing about this system, it gives you the manipulative view with the game board, as well as the numeric view with just numbers. So they're seeing 2 versions here. Manipulatives versus the numbers. And I think that this really makes learning concrete, especially at the elementary level. And students really enjoy this. It's a game that they can play at home. It's a website. As long as they have internet access, they have access to it. As well as for teachers, they love this. This could be a centered activity during a math class. It can be an enrichment activity, or as well as a remedial activity for those students who are struggling with these concepts. Now, to reiterate and review what we went over during this lesson, I basically gave an overview of how to use the tuning protocol when looking at student work in the elementary school setting, especially mathematics. Based on the tuning protocol and following these steps, we would be able to look at student work samples and pinpoint the exact issue that's going on with the student. Because before this, we would be more apt to say the student can't add. But in actuality, the student can add. This is one of the most beneficial benefits of using the tuning protocol, because it takes yourself out of the situation, and the only thing that you have to focus on is the student work sample. That concludes my portion of this lesson, and we will continue this next week. Thank you.